Hey folks, we ended our last video with knowledge of nouns and verbs expressed in C++ as objects and functions. In this video, we are going to look at how to express what an object is. Our topic is object definitions. Let's begin by looking at a simple object definition. Okay, so first we have the keyword struct. Now struct means that we are defining a custom data type. Okay, so what do I mean by custom data type? So in C++, everything has a type, and that all boils down to how much memory the object requires. But we're not going to worry about that just yet. We're going to learn about that later, or we can learn about that later if we want to. So if you remember in the previous video, we had int my age equals 0. The int part of that expression is the type. Okay, let me just color code that real quick with blue. All right. So the int part of that expression is something that I didn't explain, and that keyword int is a type. It expresses that this object will need 32 bits of memory. That's as far as I'm going to get into what type actually means. Just know that in C++, that is what the type of an object is expressing. It's expressing how much memory that object is going to require. Now in C++, there are several built-in types. We've seen two of them, int and float. There are several others, bool, char, double, void. Okay, these are all types. Okay, these are the main ones, and these are called primitives, and every object is essentially built from them. Okay, so let's get back to our struct. You'll notice that person appears after the word struct. This is the name of our new type, and we'll use this term whenever we want to create an object that is this type. Okay, so I'm going to color this purple. All right, so struct is blue. This is just a keyword. Normally it's like red or something, or it's this other color here, but for the sake of this, for contrast, I'm going to make it this color. Okay, and this will be our type. So we've already seen the syntax before with int my age ... So for our custom type, we would write this to declare that a person exists. We would write person, then person, or person Amanda, or person P. By writing statements like this, we are declaring that something of this type, person, exists. All right, so if you remember from the previous video, items in red are names. Okay, so we've got a couple extra colors. Okay, these are the names of our type. Okay, so by writing a statement like this, we are declaring that an instance of the type person is existing, and that instance is going to have the name person, or the name Amanda, or the name P. Okay? Going back to this guy right here. After we write struct person, we follow it with curly braces. Okay, and that's what this thing and this thing are. The closing curly brace has a semicolon indicating that we have reached the end of the definition for our type. This is the format that you'll see in C++ whenever you have a custom type being defined. You will always see keyword type name curly braces. Excuse me. So you will always see keyword type name curly braces and then a semicolon indicating the end. And then when you're instantiating it, you're going to see type name variable name, like this. Type name variable name. Okay? What are some traits that a person typically has? Well, they might have an age, they might have a height, a weight, an eye color, hair length, shoe size, GPA, SAT score, etc., etc. How much detail to include is our choice as the programmer, and this affects what our definition ends up looking like. So how do we express those traits in C++? Well, first, what are traits called in C++? We call them member variables. Okay, so let's add a couple. All right, so we'll say that this person has an integer age. All right, now if you remember, this is our type. So this is purple. And then this is the name that we're assigning to that variable, right? Okay, we might have int height, height in inches. Okay. Remember, this is the name of our variable, and this is the type of our variable. Okay, we might have float hair length. We might have float GPA, float unsigned int SAT score. Okay, so type, variable name, type, variable name, type of the variable, name of the variable, type of the variable, name of the variable, type of the variable, all the way, this whole thing right here, unsigned integer, and then name of the variable, okay? Our person is already kind of complicated, but it doesn't do anything yet. So what can a person do? A person can run, all right? So they might have void run. Okay, if you remember in the previous video, I mentioned that if you have parentheses like this, it means something is callable, okay? And this is called a function. Functions are required to return a value when they exit, and if they don't return anything, then their return type is void. Okay, so here's the return value of the function, and here is the name of the function. Okay, so we're still following the format. We have a type, and then we have a name. Okay, so type is what gets returned, run is the name. All right, and then parentheses indicates that it's callable. Okay, now when you run, you usually don't run at the same speed the entire time. You speed up, slow down, sprint, speed walk. So we can say that when we run, we want to run blank fast. Now in C++, we express this idea of parameterizing a value required by an action you're trying to perform via function parameters, okay? And they look like this, okay? This is our type, again, and then this is our name, okay? So we've got a function that returns some value. This is the name of the function, and then the function requires being told what to do. So in this case, it wants to know how fast you're supposed to run, and that's what this variable name is right here. And this is the data type of what we're going to tell it, okay? Now, if you remember in the previous video, we had some of these g.fillAll, g.something, g.something. This is a super good example of these functions that have lots of arguments being passed in, like the g.drawText, okay? Function definitions, if I go back to here, function definitions list the function parameters that are required. So when you call a function, slash perform an action, you pass arguments to the function. So let's expand our list of arguments for our run function to include which foot to start on. Okay, we'll use a bool. Oh, let me change this color. Bool. Start with left foot. Let me make this a little bit bigger. Okay, here's the type. All right. Here's the name. Okay, so we're just saying there's a lot of type, name, type, right? It doesn't have a name yet, so person, runner. There's our type, and there's our name. Type, name. Okay? Now, I used a Boolean value right here just because we only have 2 feet, so if you're not starting on the left foot, you're starting on the right foot. Okay? Let's take a look at this in terms of our Hello World project, so we can see this in action. Okay, so if we go to main component.h, we see that we've got, instead of the word struct, we've got the word class. We've got our opening curly brace, our closing curly brace with the semicolon. We've got a function right here. Here's the return type of the function, the name of the function. Here's the arguments to that function, one of the function parameters. It's a graphics object reference. Here's another function. Its return value is void. Here's the name of it, resized. Okay. Let's look again in main component. All right. So we've got our same, here's one object. All right, hello world application. Here's our opening curly brace. And way down here is our closing curly brace. Okay. And you notice it's got all of these. Here's a function that returns a const string. Here's the name of that function. Here's another const string. Okay, here's a return type. Here's the name. Return type, name, arguments. Return type, name. Okay. And then now if you notice here, we have a object nested within this object. Here we have the beginning of our definition. Here's our open curly brace right here. And our closing curly brace right here. All right. This guy takes, here's the name of a function, and it takes no arguments. Here's the return type. Here's a function being called with one argument. Here's a function also being called with 2 arguments. Another function being called with 2 arguments. Okay? So that's a good place to take a pause right here. So just to recap, we learned that we've got a special way of defining special types, and that all of these special types are all built up from these primitive types: integer, float, unsigned, int, boolean, double, that sort of thing. We can give it a custom name. We can give our type a special name. Our type is defined by doing the word struct or class, then the name of the type, an opening curly brace to indicate that we're starting our definition, and then a closing brace plus a semicolon to indicate we are ending our definition. And then inside of it, we declare our member variables and our member functions. Member variables are defined as you specify the type and then the name of it. And then same for the functions. You specify the return type, the name of the function, and then any parameters. And for the parameters, you follow the same pattern of specifying the type of the parameter and the name of the parameter. Type of the parameter, name of the parameter. And then when we want to actually create our custom type, we just follow the same patterns of declaring the type and declaring the name. So we have our person. So we declare a person here and then declare the name of it. Okay? In the next video, I will discuss implementation of functions. If we go back to here, I will talk about how this run function is actually implemented and how we're learning to read it. Okay? So we'll stop here and pick up that in the next video.